Welcome to this exploration of one of Earth's most dramatic natural events, volcanic eruptions. Have you ever wondered what happens deep within the Earth that leads to a volcano erupting? How does something so powerful and awe-inspiring come to life? Today, we're diving into the science and mystery of volcanoes to understand how they erupt, why they're scattered across the globe, and what they tell us about our planet's inner workings. By the end of this journey, you'll not only understand what drives these fiery giants but also gain a new appreciation for their role in shaping the Earth as we know it. The story of a volcanic eruption begins far beneath the Earth's surface in a layer called the mantle. Deep within the mantle, intense heat causes rocks to melt, forming magma, a hot, molten mixture of minerals and gases. The mantle is solid in most places, but there are pockets where heat and pressure are so high that rocks melt into magma. When this magma collects in a chamber beneath the Earth's crust, it begins to build pressure. Imagine magma as a restless force waiting beneath the Earth's surface. Trapped in this underground chamber, the pressure mounts as more and more magma fills the space. This process takes time, sometimes thousands or even millions of years. The Earth's crust, though solid, is actually made up of huge, rigid plates that are constantly moving. These tectonic plates are in a constant state of drift, pushing and pulling against each other. When they collide or pull apart, they create fractures in the Earth's crust, and these fractures become pathways for magma. Once magma finds a weakness in the crust, perhaps a crack, fissure, or vent, it begins to move upward. As it rises, it brings with it gases like water vapor, carbon dioxide, and sulfur dioxide that were dissolved in the molten rock. The closer it gets to the surface, the lower the surrounding pressure, causing these gases to expand. Picture a bottle of soda. When sealed, the carbonation is contained under pressure, but when you open it, the gas bubbles rush to escape. This is similar to what happens with magma. As it nears the surface, the gases inside it expand, adding even more pressure, sometimes explosively. When the pressure becomes too great for the crust to hold back, the volcano erupts. Magma surges through the vent, reaching the Earth's surface and spilling out as lava. Depending on the type of volcano and the composition of the magma, eruptions can vary widely. Some are slow and ooze out lava, creating rivers of molten rock that flow down the sides of the volcano. Others are explosive, sending massive clouds of ash, gas, and volcanic rock high into the sky in a matter of moments. Volcanic eruptions aren't just a spectacle, they are powerful agents of change. Lava flows reshape the landscape, creating new landforms and depositing minerals that enrich the soil. Explosive eruptions can spread ash across vast areas, sometimes blocking sunlight and even affecting global temperatures for short periods. Eruptions can also create new islands as lava cools and solidifies upon reaching the ocean. In a way, volcanoes are Earth's way of recycling and renewing its crust, building up land and transforming the environment. But the story of a volcano doesn't end with an eruption. After the eruption, the volcano begins to cool and the activity slows down as pressure decreases. In some cases, eruptions can continue sporadically for years, while in others, a volcano may go dormant, waiting for the conditions to rebuild enough pressure to erupt again. Some volcanoes may even become extinct with no more magma flow or possibility of eruption. Over time, the material ejected by volcanoes contributes to the Earth's atmosphere and landscapes. Volcanic gases help create clouds, influencing weather patterns and precipitation. The ash and rocks contribute to soil fertility, making volcanic regions some of the most productive agricultural areas in the world. Volcanic activity has played a significant role in shaping the Earth's atmosphere over millions of years. By releasing gases, particularly water vapor, early volcanic eruptions helped create the conditions that allowed life to thrive. Volcanoes are awe-inspiring, but they also pose serious risks. Lava flows, ash fall, and pyroclastic flows, a fast-moving mix of hot gas and volcanic materials, can be devastating to nearby communities. Preparing for volcanic eruptions is a challenge because, despite advances in technology, predicting exactly when a volcano will erupt remains difficult. Scientists, however, have developed ways to monitor signs of volcanic activity. Instruments detect ground deformation, gas emissions, and seismic activity, all of which can indicate that an eruption may be approaching. These clues allow scientists to give warnings, helping to save lives and reduce damage when a volcano shows signs of activity. Volcanoes, while destructive, have a certain beauty and purpose in the grand design of our planet. They are evidence of the dynamic, constantly changing nature of the Earth. They remind us that our planet is alive, with forces at work beneath our feet that have shaped continents, influenced the climate, and created habitats for countless species. And that, in a nutshell, is how volcanoes erupt. From deep within the Earth's mantle to the explosive power we see on the surface. Each eruption is a reminder of the incredible forces shaping our world. If you found this journey through the science of volcanoes fascinating, don't forget to like, subscribe, and hit that notification bell so you won't miss our next exploration into the wonders of Earth. Thanks for watching, and remember, the more we understand about our planet, the more we can appreciate the power and beauty of nature.